Okay, given that x minus 3 is a factor of x cubed minus 5x squared minus 2x plus p, show that p equals 24. Now, first of all, we'll call this, right, f of x, right? Because essentially it is a function of x, right? It's like a function machine. You put x values in, you get something out. So we'll always call it f of x. And then there's this remainder theorem, okay? The remainder theorem goes basically like this. If x minus a is a factor, okay, of f of x, right, of this function, of this cubic. So if it's a factor, now I'm using a just for a general value here, but if x minus a is a factor of f of x, this implies then that f of a, in other words, if we actually set x to be a, will equal to 0. So that's the remainder theorem, okay? So it will be a factor, right, if f of a comes out as 0. In other words, it'll divide into it. A factor means it divides into it perfectly. But we're told here that x minus 3 is a factor, okay? Right? We're actually told that. It says given. So that implies then, right, going by the sort of theorem up here, that implies then that f of 3 is equal to 0, okay? Because a in this case is 3, isn't it? Yeah? So we put 3 in. So f of 3 is 0. So we can use that then in this to work out what p is. So if f of 3 is 0, we'll set x to be 3, put 3 in, so 3 cubed minus 5 times 3 squared minus 2 times 3 plus p, and that will equal to then, of course, 0, yeah? Okay, we're expecting then f of 3 to be 0. Now we can work this out, we can use a calculator on this, right, because it's in the calculator exam, okay? If you want to work them out separately, that's fine, or you can work them out in one go. Okay, and you do that and it comes to minus 24. So that means then p is equal to 24. Okay, job done. With part B then, it says solve this, right? Now in order to solve this, it's a bit like when you solve a quadratic. When you solve a quadratic equation, we can factorize it, okay? And the same with a cubic. If we factorize it, then we'll be able to solve it. So by factorizing it, we need to put it into brackets, okay? So we'll forget about the fact it's equal to 0 for a minute, okay, and that's what we want to solve. We'll just factorize it, we'll put it into brackets. And remember, with a cubic, we're going to have 3 brackets, okay? Now what's good is, I know one of the brackets already. Because x minus 3 is a factor, I know that that will be one of the brackets, okay, because it divides into it, okay? So we can, if it divides into it, we can have that then as a multiple of something else. And because we're expecting 3 brackets, of course, there's going to be another 2 brackets here, okay? Another 2 brackets. Now I don't know what those brackets are, but when you've got 2 brackets, we don't know what they are, but if you think about it, when you multiply those 2 brackets, you'll actually get a quadratic, okay? Because 2 brackets multiplied, when you do FOIL on it, you'll have something x squared, something x, and a constant. Now what's good is, right, I know it'll be 1x squared in this case, okay? I know it'll just be x squared. And the reason why I know that is because I look at what's in front of the x cubed here, and it's just 1, isn't it? Okay, it was 1x cubed. So whatever's in front of the x cubed will tell me what goes in front of the x squared here. That's always the case, all right? And you can prove that by multiplying out, and you'll realize that if I multiply out here, I'll have x cubed, which is exactly what I've got here. Now I don't know what's in front of the x, so I'll put that as bx, and I don't know what's in front of, I don't know what the constant is, so I'll just put plus c. Next job then, right? We're now going to look at the coefficients of well, any one of these really. You could look at the x squared or the x, okay? But also we're going to look at what the constant is, okay? So I'm going to actually then look at the constant to start with, okay? And essentially what I'm doing is I'm equating both sides, right? In other words, if you look at the constant on this side, it's plus 24, isn't it? Yeah? 24, yeah. Now, because they're equal, because they're identical, I've got to expect the constant on this side to also be plus 24. Now, if you think about it, the only way I can get a constant from here is by multiplying the lasts in the brackets, yeah? By multiplying minus 3 by c. That's the only way I can get a constant. Because if I multiply any other term, you know, x times whatever, it'll have x in it, won't it? Okay, I don't want x in it. So the only way I can get a constant is by multiplying them. So minus 3 times c, minus 3c, okay? Now, if I've got that, then I can clearly then work out what c is, because we times in here, take that minus 3 over, and divide. So you get minus 8 straight away, okay? Now, then we'll also equate, we'll go for the x squared, okay? Now, what I mean by equating then and looking at the x squared is how many x squareds have I got? What is the coefficient of it? What's in front of it? And on this side is minus 5. Okay, it's minus 5x squared. So I'm going to expect exactly the same on the other side. Where do I get the x squared here? Okay, what goes in front of the x squared when you multiply all this out? Now, to get the x squared, think about it. I could times the x by the bx, couldn't I? That will give me x squared, because x times bx is bx squared. What's in front of the x squared? Well, it's a b, isn't it? Okay, so x times bx squared, so b's in front. I can also get x squared when I multiply the minus 3 by the x squared. So think about all the ways you can do it. There's two ways, right? So you do it that way and also this way. Now what's in front then? What will be in front of the x squared? Well, it'll be minus 3, okay? So on the right-hand side, the combination of the x squared terms will give me this, right? It'll be bx squared take away 3x squared. So in terms of what's in front of the x squared, it'll be b minus 3, okay? And both sides are equal. This has got to equal to minus 5. So then quite simply then I can take that over the other side and I'll get b out then. So b then turns out to be minus 2, doesn't it? Okay, so I can then put in my b, which is minus 2, and put in my c, which is minus 8, okay? So I'm replacing them in here then. B is minus 2, c is minus 8. And then I'm going to factorize this quadratic here. I can do that. Quite simply this time, I need two numbers that multiply to give minus 8. Two numbers multiply to minus 8 and add up to give minus 2. Now those two numbers, okay, if you think about it, will be that there, minus 4 plus 2. So then, when we want to solve, right, because it did say to solve that equals to 0, didn't it? Or, you know, it wanted this, didn't it? 5, the cubic equal to 0. Well, instead, we can look at the two brackets, 3 brackets rather, equal to 0, okay? Okay, so instead of considering the whole cubic, we consider the 3 brackets. The 3 brackets equal to 0. Something times something times something equals to 0. So if something times something times something equals to 0, one of those things has got to be 0. Okay, so that means x will equal 3, or x will equal 4, or x will equal minus 2. Okay, part C says find the remainder when f of x is divided by x minus 2. Okay, so what is the remainder? Okay, well, to get the remainder, just like before with the remainder theorem, you just work out what f of 2 is. Okay, so because it's minus 2 there, a in effect is 2, so we work out f of 2 is. Now it's not going to come out as 0, because it's not going to come out as 0 because this wasn't a factor. But what we'll do is we'll just put 2 now into my cubic. Okay, and if we work this out, okay, we obviously you can use a calculator on this, right? And we end up with 8, I believe. Yeah, and we're done.